Okay, chapter 9. Let's get into it. The uh, problems or the homework starts off with a multiple choice question where you have the successful entertainer, LeBron James, earns astronomical amounts. Others just earn small wages. Um, and the question becomes one of why would LeBron James's earnings consist of wage plus a rent? The idea here would be is that the rent is due to his, well, a very kind way to say it, his unusual abilities. Um, just want to draw. And it's just a definitional question of what rent consists of. Okay, well, let's get to something a bit more interesting here. Number 2. So I've got a market price of 70. Got a cost curve here where the marginal cost is equal to 0.006 q squared plus 50. And essentially, we need to, again, set marginal revenue equal to marginal cost. The idea here is that for these competitive firms, again, the marginal revenue is equal to the price. So 70 equaling 0.006 q squared plus 50 equals 20 equals 0.006 q squared. Q squared would mean that I'm taking my 20 my calculator is not working. 1 second here. Oh my gosh, my calculator is not working. Okay, 1 second here. Okay, here we go. 20 divided by 0.006 gets me a q squared of 3333.33. Again, your numbers are going to be a little bit different if you don't have these exact functions. And then the square root of that is 57. .73, so it would just be to 2 decimal places, so 57.74. Sorry, 74. Once we round. Okay. And the profit, well, in this case, since it's perfectly competitive, I don't need to calculate anything. It would be 0. You could affirm that for yourself by taking this quantity, multiplying it by the price to get your total revenue. And if you put in that same quantity into your cost function, you should get the same numbers here. What would this firm do? Well, it would continue to produce because it's not losing any money. It's going to have the firm will have a let's see here. Sorry, I got to connect here everything here. 1, the firm will produce in the short run. The firm will realize essentially economic profit in the long run, which would mean that the accounting profit is 0. Which would mean again that our part of may or may not have a business profit, because that would be another way of saying business profit would be the accounting profit. And this firm would continue to produce. It wouldn't shut down. Avocados. Okay. Market price is 28. That would mean that my marginal revenue is also equal to 28, and my marginal cost is equal to 0.006 q squared plus 22. And I'm being asked what the profit level is. Well, I can't do that unless I find out how much they're going to make. So that would mean I need to set MR equal to MC. That would mean that 28 is going to equal 0.006 q squared plus 22. It's going to equal 6 equals 0.006 q squared. 6 divided by 0.006 is 1,000 equals q squared, and then the square root of that is 31.62. So multiplying that by 28 gets me 885.44. Total costs are going to equal 0.002 times 31.62 squared plus 22 times 31.62 plus 750. Okay, well, let's throw that all in there. Now, because I'm doing this rounding, I'm going to get slightly inaccurate numbers, but we'll just have to live with it. 1646. Okay, that's why my number's not looking good. Sorry, I mistyped it in. And you would think, hey, Shiting, given how you are, I'm surprised you double checked anything. I would say, stop being a mean person. Well, I probably wouldn't say it that nicely. I'd probably use a swear word. I think this is accurate. So my total costs here are much higher. I'm actually showing a negative profit. If I calculated everything. Oh, sorry, not squared, cubed. Okay, 1 second here. Uh, 31.62 cubed plus 22 times 31.62 plus 750. Okay, sorry. Changes the number a little bit. 1508. And then just to confirm here. Yeah, so I have a negative for mine. You might get a slightly different result depending on what they gave you as a market price. Okay, now I've got an inverse demand function. Usually what I like to do is I like to try to draw things out here because it's pretty quickly, it's difficult sometimes to make sense of the numbers if you are missing things here. So we've got a general form of the inverse function of a minus b pq. And with that, that would mean that right, and we're trying to solve for this right here. Well, based on this function here, definitionally, then all we would have here is that the consumer, the area of that triangle would be 1/2 base times height. Which in this case, if we algebraically manipulate our market price of A divided by 2, so that's my A divided by 2 is my market price. If I put in a 0, I can find this price here. So that would mean that P equals A minus B times 0. Which means that my right, so my function here, so if this is just multiplied by 0, then I'm just left with P equals A. This Q here, right, now we need to solve for this Q. So this is going to be sorry, A divided by 2 equals A minus B P Q. A equals 2A minus 2BQ, which gives us a general form here for our consumer surpluses, which is 1/2 base times height of A squared over 2 times 2 times 2 is 8B. So all that I did here is I then, sorry, I've run out of space here successfully. I took my solution for the market price right here, substituted it into my inverse demand function to be able to solve for Q, and then multiplied it out. Okay, I'm running out of space here, so I'm going to erase some of this here, sorry. Oh, really? This is not bad, this eraser is. Never mind, that's fine. Sorry, this is just me very badly managing my space that I have available to me. Let's make this a little bit less theoretical, thank God. So we've got an inverse demand function right here. We've got a market price of 40. And we now need to solve this area right here, which would be 1/2 base times height. So that would mean P equals 60 minus 2 times 0, because that would be, we need to find this price right here, the y-intercept. So 2 times 0 gives us nothing, so this is 60. And then we need to put in a price of 40 equals 60 minus 2Q. Negative 20 equals negative 2Q. Q equals 10. And so then 1/2 times 20 times 10 would be 100. Okay. Now, if the government imposes a tax that raises the price to 45, what we can see here is that we're now going to solve this, and we're just going to have a smaller consumer surplus. It would be 15 times 10, so 150, if you're given the same numbers that have been given here. And we get then to the final question here is the monetary difference between what consumers are willing to pay and what the good actually costs. Oh, sorry, it's just defining it. Sorry, I don't know why I'm saying this. The consumer surplus, though, here is going to, I already answered it here, it's going to decrease with any tax. That's what we have right there. Oh my God, that was horrible. Sorry for how messy that was. It did not need to be that messy. I'll write smaller. Okay, let's turn to number 6 here. Supply function of 10 plus P. Produce a surplus if the price is 20. Again, very helpful to just draw out the graph for yourself. So now I'll still draw in the demand function, even though I don't really need it here, but my supply function here, the price is 20. The supply function is defined by Q equals 10 plus P. When that's 0, which would be where I'm looking for the intercept with the y-axis, would be where P is equal to 10. So now we need to find this Q. So that would be where Q equals 10 plus 20, that $20 price. So that Q is going to equal 30. So now it's 1/2 base times height, or it's 1/2 times 10 times 30. So that would be 300. That would be, where did I make a mistake? Let's see here, 20. Sorry, I made a mistake somewhere. Oh, sorry. -10. Sorry, sorry, I lost my sign there. And obviously, the reason why that becomes important then is that this is 15. Which doesn't actually solve our problem here. Let me pause it rather than just keep wasting our time here. Let me solve it. Okay, I'm just going to unpause this. I don't see any way. I mean, I even had to look and see what did the authors think that the answer was, which I don't try to do here. The authors think that the answer is 400. I don't see any way. The only error I saw that you could theoretically say I made would be that nothing would have been sold at negative prices. So that instead of having a triangle, that we had sort of a very small trapezoid. I don't think that that's what they're intending. I'm thinking that there's an error here. As long as you're following the logic of what I did, which I'll repeat, you're going to be okay. So what I did here is I was given a market price and I was just given a inverse supply function. And what I did was with that inverse supply function, I backwards calculated what the y-intercept was for the supply function, which would have been inserting in a 0 for the quantity. So 0 equals 10 plus p. Subtract the p, and so then I was left with negative p equals 10 or p equals negative 10. That's how I got the negative 10 here. Then go back to the inverse supply, or sorry, just go back to the, not inverse supply, just the supply function and put in the price as 20. So 10 plus 20 is equal to 30, which is right here. And then theoretically, let's just say that you can charge negative prices. Then essentially what you would have had is 1/2 times 20 minus negative 10 times 30, which would have been 1/2 times 30 times 30, which would have been 1/2 times 900, which would have been 450. I don't see how they get 400. I honestly do not see it. There's no way I see how they could have done it that way. So, I don't know. Maybe Paraloff was drunk or something like that. If any of you who are watching this video see where I have made the error, totally email me and help out the rest of the class. Okay. I'm just going to move on here. Because you're not going to, like, we're dealing with the difference between what the publisher is trying to helpfully provide to us to help to understand the material versus what I'm going to give you as the problem set in the exam. As long as you're understanding the theory of what I'm talking about, we are all good. Okay, so let's look here. We have a marginal cost schedule, and we're given a market price of $3, and we need to solve for the producer surplus. Okay. So here, what we need to do is we need to, sorry, 1 second here. Okay, so we've got a market price of $3, calculate the producer surplus. Then what we need to do if the market price is $3, we need to continually add up the difference between that market price and the various marginal costs. So here would be a +2, here would be a +2, here would be a +1, here would be a 0. And quantities 5 and 6, here we'd see that the marginal cost would exceed the price. Now, this is multiplied by the quantity. So 1 times 2 is 2. 2 times 2 is 4. 3 times 1 is 3. So here I've got 7, I've got 9 as my total, not really my total cost, but my summed up marginal cost. 3 times 4 3 times 4 is 12. Now, over here, let's put this in red because this is going to be now at the negative point here. So this would be -1. This would be -3. So what essentially we're doing here, right, if we want to understand this graphically, is my supply function. I've got a market price of 3, and essentially what I've said is that this is where it's at 1 and 1. This is where it's at 1 and 2. This is where it's at 3 and 2. And 3 and oh, my picture's horrible. So essentially, again, we're trying to sum up those differences between the marginal costs and the price here. So in my case, I just have a total difference here of 3. But again, your numbers may be different than mine. Okay, 10 identical firms, market price of 20. Each firm has a marginal cost of 2Q. So we've got a marginal cost of 2Q. Find the total producer surplus. Okay, well, we need to know how many things are going to be produced. That would be where marginal revenue is equal to marginal cost. So 20 equaling 2Q, Q equaling 10. That would be now for 10 identical firms. That would mean that the total market quantity is going to be equal to 100. That would mean that as well for each firm that's producing then our difference at, now you would have to do this, you would have to sum this up for 1 through 20. So the most helpful, I'm not going to go through all those steps here, but again, as you kind of understand at least the theory here, you would then create a table essentially where you would go 1 through 20, so on and so forth. And then you would, as you put in those marginal costs, 2 times 1 would be 2, and that would be a difference with 20 of 18. When you put in 2 times 2 is 4, that would be a difference now of 16. 2 times 3 is 6, so now my difference is 14, right? And you would go on, and then you would sum all that up, and that would be your answer there. Sorry, I'm just trying to not make these videos too long. It's really designed to help you, and hopefully it's doing that. Although I have my questions about whether I'm actually doing that. Okay, USDA is saying we should eat 5 servings of fruits and veggies, and that the price of salad is going to increase 7.2%. Output's going to increase 3.5%, and growers' revenue would jump 7.3%. And we're asked to kind of talk about how things would change based on that. Well, if the government is providing these recommendations and essentially telling people to eat more veggies, right? Fruits and veggies, it shifts out the demand curve in this way. And essentially, it's ended up increasing the benefits of fruits and vegetable servings with the subsidy that it would refer to here with the surplus, right? That the consumer overall is going to gain more of a benefit from this. And, and that essentially, right, especially if they're able to keep that original price, what we would see is that the surplus itself would grow, and that we'd have that greater benefit of the fruit and vegetable servings. Okay, number 10. Here we're asked about what are the implications of a deadweight loss, and essentially it's that in this case here we're not allocating efficiently. We're either, sometimes it's too much if the good has a negative externality, or not enough if it has a positive externality. It's just not efficient. And so when you see deadweight loss, think inefficiency. Number 11, we were talking about the market for wheat, and we need to calculate the amount of the deadweight loss. Well, first thing we need to do is we need to find the competitive amount. That would be where demand equals supply. So that'd be 120 minus 1p equaling 20 plus 4p. Again, my numbers may be different than what you're presented with. That'd be 120 equals 20 plus 5p. 5p equaling 100, p equaling 20. Q equaling 100. Now we're saying that they are going to limit things to 95. So again, it is generally helpful then to graph things out. So if they limit things to 95, we now have to solve for this triangle here, which would mean that what I need to do, the only thing I need to do here is I need to put that 95 into both the supply function and demand function to find out the base of this triangle. I already know the height of the triangle. The height of the triangle is equal to 5. And remember, I'm just doing 1/2 base times height. So if I put in a quantity of 95, it's going to be 25. And then on the supply side, it'd be 95 equals 20 plus 4p minus 20, so it'd be 75 equals 4p, p equaling 18.75. So that would be 1/2 times 6.25 times 5. Gives me a number of $15.625 total amount of my deadweight loss. Let's review the steps here. I drew this out and I solved for the equilibrium price and quantity. I found that to be 20 and 100 just by setting demand equal to supply. Then I was told of the restriction of 95. Put that into your picture and you can pretty easily see that the height of that triangle is 5. And I just need to solve for the base of that triangle. And I can find the base of that triangle by putting in a quantity of 95 into each of the functions and solving for the prices, which I did. Found a difference of 6.25 for the base of that triangle. In essence, I was just taking 1/2 base times height. Okay, number 12. A definitional question or a theory question. Which of the following is not a factor that could limit the entry of firms into a market? That would be a fixed cost thing. In this case, fixed costs are not going to, it's not going to be any factor that affects the entry of the firms. This is going to be largely issues that have to do with the profit levels for the firm, since we're talking about competitive markets. Okay. Number 13. Suppose you analyze a competitive market and you've got a inverse market demand, a market supply, and a total cost function. What's the marginal cost? Well, the marginal cost will just be the first derivative of that. So it would mean 0.4Q. Assume that the industry is at the long run equilibrium. How many firms are currently in this market? Well, what we need to do to solve for that is we're going to need to find out what the market quantity is. So to get that, we're going to have to set the okay, so negative 0.01Q equaling negative 80. Yes, I know I could just don't want to make a mistake here. Now, each firm is going to produce where marginal revenue equals marginal cost. I need to find out still the price here. So 100 minus 0.01 times 8,000. So each firm is going to make 20. 8,000 divided by 20 is going to get me 400 firms. So my market quantity of 8,000 divided by sorry, no, I think I jumped a step here. Sorry. No, yeah, sorry. I didn't need to do that. 20. Sorry, my price is 20. I need to now set that equal to 0.4 Q. Q is equal to 50. So each firm is going to be producing 50. So I set my MR, which is my price, $20 equal to 0.4 Q, my marginal cost. 8,000 divided by 50 is going to get me 160 firms. And what we need to, the final part to here would be, where does the long run inverse market supply curve become upward sloping? Well, that would be at the point where I am meeting my average variable costs. Where are my variable costs? That would be 0.20 Q squared. Where is that going to equal at least 20? Right, because that would be what price, if this is the price that's being charged, at what point, at what point, at what quantity point would we start producing a positive amount? And that I'm getting to be 10. Okay, now we've got Nashville. Operating a limited number of cabs in the city. And so we have to figure out now, theoretically, again, what's going to happen to government revenue if they decide to charge this licensing fee. Well, we know that the government's going to get more money. So we know that the government's going to get money. We also know that theoretically there should be a deadweight loss. So we already know it can't be that. We wouldn't necessarily know based on we don't have a great deal of information about elasticity. We don't really know what the effect is going to be. If we're comparing the two, the welfare loss versus the taxes captured. So we know that the government's going to get money, but it's going to be difficult to make any comparison such that we could see that it's the exact same amount as the deadweight loss. We can't say that for certain. And if we had to pick the best option would be is one where the welfare loss would be less than the fee, right? Because then all we would have to do is take all that license revenue and redistribute it to those who had some sort of welfare loss. It would be essentially what we've done with NAFTA and other things, where we basically compensate those who lose out from some action. Okay. Okay, so let's look here. So we've got a demand function for wheat, a supply function, and we have a subsidy of $1. Well, essentially what we need to do, I'm going to try to make this a little bit faster. I see I'm at the 40-minute mark, and I don't want these things to be that long. You're going to set demand equal to supply, because we need to find out what the equilibrium is. And the reason why is because, again, I need to draw my picture of what things look like. And what I can see is that producers are being given a subsidy of $1. So what is that going to mean? If they're given a subsidy of $1, it's going to shift out my supply function like this. And so that would mean that in terms of my supply function here, I'm going to have to resolve the quantity. I'm going to have to resolve it again where the subsidy is provided, such that it shifts up by 1. So I need to solve for the equilibrium price and quantity. Step number 2, find the inverse supply function. Why? Because in step 3, you're going to shift the inverse supply by $1. You're going to increase it by $1. So if you've done all these 3 steps, it's going to get you this. It's going to get your equilibrium price. And then you're going to have to basically solve your consumer surplus, producer surplus, revenue, and deadweight loss by filling in all these parts of this graph that you've drawn here. Right? Because when you shift the inverse by $1, then in step 4, you're going to resolve the price and quantity, equilibrium price and quantity. And you're basically going to fill in the missing information to be able to solve for your consumer surplus, producer surplus, and deadweight loss. And government revenue. It's basically going to become a challenge of triangles. I'm sorry here. I realize I'm taking kind of a shortcut here. I just don't want this video to become very long. If you're having problems with number 15, email me and I'll make you a separate standalone video that just goes over this. What would we in general, though, see, even if you didn't want to calculate these things? What do we know would be true? We know to be true that the equilibrium price should decrease. That's the whole point of the subsidy. That the equilibrium quantity should be increasing. That the consumer surplus should be increasing. That the producer surplus should be increasing, and that let's see, make sure 1, 2, 3, 4, 5, yeah, and that the government revenue is decreasing, right? Because the government's obviously giving out this subsidy, and then you would have to calculate the deadweight loss, which would mean calculating the equivalent of this triangle right here. Okay. Here it looks like you are plotting things out. This becomes a little bit difficult for me to do here with this PDF that we're dealing with here. So essentially, again, what you're doing here, it's just like everything here. We're solving areas of triangles. That's how we deal with consumer surplus and producer surplus. Um, so if we were to look at this relative to the price floor, what happens when it said we provide these deficiency payments, meaning that we pay producers when consumers don't buy enough? Well, in essence, it doesn't make a difference. Farmers would be equally well off. Either they're going to get higher prices from the consumers that remain, or there's going to be fewer customers, and the government's just going to give them the difference. Um, Consumers, if they if they have this deficiency payment program, consumers are going to be better off because they're going to pay these lower prices, and they're just going to buy the amount they'd want to buy. Government making up the difference. And if now consumers are overall better off, then the deadweight loss theoretically should be smaller because you don't have that large reduction of people buying things because the prices are higher. Okay, now we've got a somewhat similar discussion here with the National Park Service. Same kind of discussion, though, going on here where we are essentially calculating areas of triangles and comparing. It wants us to do relative to the price floor. What do we get with a quota? So again, the difference between the two would be is that with the price floor, we are making the price artificially higher to be able to lower the quantity versus just saying no, the quantity is going to be lower. If that's the case, then consumers, from their perspective, are equally well off, right? It doesn't really cause any difference. Quantity is still lower regardless. But now the deadweight loss is essentially the same. The deadweight loss here being again that reduction, and we can see here that that reduction, that size of the area of this triangle here is the same as the area of this triangle here, which is why we would say that those two deadweight losses are equivalent and that consumers are equally well off. Okay, now we've got more wheat here. God, Paraloff really likes his wheat. So in this case here, got a demand and supply function and a price of 5. Again, just in the interest of time here, you're going to solve for the equilibrium price and quantity. And now you're going to insert that artificial price of $5. I haven't solved it here, but essentially what you would do, draw your picture. That way you can kind of organize where everything is. You would have your price here that you would have solved for. You would have your quantity that you solved for. I don't know where that $5 is, if it's a floor or a ceiling. Looks like it's a floor from my guess here. So the 5 would be up here, which would mean then that you're solving substituted into the supply function and demand function to know what your surplus amount looks like. But now you're going to solve for the area of that deadweight loss, which is going to be right here. And if instead they did the deficiency payment program, you would just need to solve for what that that difference is between this point and this point. You would need to solve that times the $5 price, that difference in the quantities. That's going to be your amount of your deficiency payment. And then your deadweight loss is actually only going to be, it's going to be a smaller portion of this because your producers are no longer losing out. Okay. 19 is a definitional question. In this case here, where the supply is where the supply is perfectly elastic, then you would need to look at the demand function. What we see here is that because the demand is inelastic, right, and we're told that essentially down here, because we have a inelastic demand curve, what we're going to see is that there would be no deadweight loss because there would be no height to that triangle. Okay, everyone, this continues, but now my daughter is in the office as well, and so there'll be some background noise, and so I'm sorry. Just to go back to this, okay, so we had a perfectly elastic supply curve, and we knew that because it was horizontal. If we wanted there to be no deadweight loss, that'd be the only way you could create it where there's no deadweight loss with a perfectly elastic supply curve. Now, for the demand curve, that the landline demand and supply intersect at the same point, then essentially what you would need to create for yourself here is a situation where the demand curve was completely vertical. So what you would need here is a situation where you've got your demand like this, and that the supply for wireless versus landline is no different, right? So if this was landline, then this is wireless, and there'd be no difference in the quantity between the two. And you only get that if the demand curve is perfectly inelastic. Okay. Again, I'm going to try to keep this short so I can keep this at an hour or less. Here we've got a horizontal supply curve, a regular downward sloping demand curve, and we're asked to solve for the subsidy, consumer surplus, and change in welfare. Essentially, what you would need to do here is that you've got a in my case here, I've got one where the marginal cost is 5 cents, hence the supply curve right here. That the amount of the deadweight loss from a tax is 2.6 billion. That for every dollar in tax revenue, that the efficiency cost is 53 cents. And so what? Oh, geez, this gets really complicated. This is my first time kind of encountering this problem here. Sorry, just give me a second here just to look at this. I'm not really sure you're going to learn a great deal from this, to be honest. I'm going to do my best to try to find a way to remove this. I don't think you're actually learning a great deal from this. I'm not just doing it because I'm trying to get to the end here, but this is just a very complicated way to get at what I think you already know. And to be honest, we can get it even right here. Deadweight loss from a quota. So for here, I'm going to do my best to remove number 20. If we wanted to see what the deadweight loss was from the quota, we need to look at, sorry, I'm just trying to read this as quickly as I can. Okay, so from the quota, Actually, it's pretty easy. Because domestically, the world price for sugar is half of what it is in the US. So if I say that people have to buy American corn, then no one's going to be buying it at the world price, which would then mean the entire market's wiped out, and this is all my deadweight loss. Okay, so CD&E. Again, the reason why here being the difference because if I stop people from buying it at 11 cents a pound, then people have no choice but to buy it at 27 cents, which would mean that the world market essentially doesn't exist for these consumers. Taking it further, for the same problem, what would the consumer surplus be? Well, it's going to increase, and it's going to increase by A minus C. Let's go back to this here. So that would mean that it's increasing by A, but reduced by C because now I'm at Q1 point, that lower price point that goes along with the 11 cents. So it's going to be increased by A, reduced by C. That's essentially what we should see here. And then for the producer surplus, well, they are gaining C, but they're losing D. They're losing D triangle because, again, they have that reduction in the quantity. So it'd be C minus D. Or, sorry, C plus D, sorry, because they're gaining, the world producers are getting that portion D. And then in terms of the entire surplus, it's going to be increasing by area AD. And where do we see that? Well, we see that by what they're gaining here by the demand curve shifting out in terms of people being able to purchase this extra amount that comes from the world at the lower price. Okay. I think this is the last problem here. The only thing we need to calculate here is the amount of the cost of the subsidy to the government. Which would mean here, I think, no, we don't have a good picture here. Sorry. In terms of the cost of the subsidy, it's going to be the amount of the rose stems. So from here, 1.25 to 1.33. So that'd be 0.08 billion rose stems times 2. And that's going to give us our amount of the subsidy. So it'd be 0.08 billion times 2 will give you that amount. And again, your numbers are going to probably be different than what I just had here. Okay, well, I kept it within 40 seconds under an hour, and I'm going to go back and I'm going to remove number 20. Again, the point of these videos is that, yeah, you're going to get a lot of answers here, and it's going to make these homework sets more manageable and something that you learned. And the idea is that it's a building block to setting you up so that the problem sets seem so difficult and that the exam doesn't seem so difficult. So again, there is a method to my process here. And the idea is that, again, intermediate micro theory isn't going to be easy no matter how you do it. But the idea is that when you get to the problem set and you get to the exam, that there aren't any surprises. Okay.